All right, this video is for showing how to identify more trig identities. Let's get cracking. So the first one is cosine over 1 plus sine plus 1 plus sine over cosine equals 2 secant squared. So in this, I'm definitely going to keep the simple side, and that's what I want to try and match. So the first thing that I'm going to do is I'm going to give them common denominators. So I've got cosine over 1 plus sine. I'm going to leave a little bit of space, plus 1 plus sine over cosine. And the first term, I need to multiply it by cosine over cosine. The second term, I need to multiply by 1 plus sine, top and bottom. Now, combining these back together, I have cosine squared. And then let's FOIL this out. 1 times 1 is plus 1. 1 times sine is plus sine. FOILing it out, sine times 1 is plus sine. Sine times sine is plus sine squared, all over cosine times 1 plus sine. So we're going to clean the top up just a little bit to give us cosine squared plus 1 plus 2, because 1, 2, 2 sine plus sine squared all over cosine times 1 plus sine. All right, so now if we use our Pythagorean identities, we have sine squared and cosine squared, and so that gives us 1. So sine squared plus cosine squared equals 1. So we're going to move this up and we're going to rewrite this as 1 plus 2 sine all over cosine times 1 plus sine. Simplifying it a little bit more, we've got 2 plus 2 sine all over cosine times 1 plus sine. All right, let's see what else we could do. We could factor 2 out of each term in the numerator, giving us 2 times 1 plus sine all over cosine times 1 plus sine. Hey, look at that, everything's multiplied. We can cancel these out and simplify things a little bit, and we're left with 2 divided by cosine, which is the same as 2 times 1 over cosine, which is the same as giving our reciprocal identities 2 secant. And now we have both sides matching each other, and we have proven this trig identity. For example number 2, we're asked to verify that sine divided by 1 plus cosine equals 1 minus cosine over sine. So I'm going to choose to keep the right side and to try and match that. And I'll do a quick description of why. If I have a plus b times a minus b, my middle terms are going to cancel out, and I'm left with a squared minus b squared. And I'm using this on the left-hand side to try and simplify things a little bit. So let's get going. We've got sine over 1 plus cosine. And to simplify, we're going to multiply top and bottom by 1 minus cosine. Okay, so 1 minus cosine. And what I'm left with is on top, sine times 1 minus cosine. And on the bottom, 1 times 1 is 1. So I have 1, and then the middle terms will cancel out if I did minus cosine plus cosine. Minus cosine squared. Now why do I do that one? Remember that sine squared plus cosine squared equals 1? If I subtract cosine squared from each side, I get that sine squared equals 1 minus cosine squared. And I can use this Pythagorean identity to substitute 1 minus cosine squared as sine squared. So let's go ahead and do that. We've got sine times 1 minus cosine all over sine squared. And sine squared is the same as sine times sine. And one of these, they just kind of are one in disguise. That's how I like to think about it. And what I'm left with is 1 minus cosine all over sine. And it equals the right-hand side. And I have just proven this trig identity. And so sometimes to simplify the bottom, if we use, or to simplify a denominator or fraction, we can use this property when working with trig identities. So this might be something to try if you get stuck. All right, let's get going with example number 3. We have tangent of x minus sine negative x all over 1 plus cosine x equals tangent x. So this, I'm definitely going to choose to simplify one side. And so I want to match. My goal is to get the left-hand side to equal tangent of x. So the first thing that I'm going to tackle is this sine of negative x, right? It's the first thing that I want to do. And sine is an odd function, meaning that sine of negative x is equivalent to negative sine of x. And I'm going to put that in my, proof first. And we've got tangent of x, and minus a negative is going to be plus sine x, and then all over 1 plus cosine x. All right, so from here it can get a little bit tricky, but then what I'm going to try and do is breaking it all down into sine and cosine. So tangent is sine over cosine plus sine x over 1 all divided by 1 plus cosine, right? Now, how could this help me out? What I'm going to do is I'm going to give a common denominator up top. I'm going to multiply this sine by cosine x over cosine x. And rewriting these as a one fraction, I get sine times, or sine x plus sine x cosine x all over cosine x, big divider, by 1 plus cosine. And this helps me out because then I can do the keep, change, flip, and I can have sine x plus sine x cosine x all over cosine, which is my numerator, and multiply it by the reciprocal of the denominator, which is 1 over 1 plus cosine x. Now how does this help me out? We're getting pretty close. Remember that tangent is sine over cosine. So I'm going to try and get it to look like that. I can factor a sine out from each term in the numerator. So it would leave me with sine over 1 plus cosine all over cosine x. And then I'm multiplying by 1 plus cosine x. And hey, these are all being multiplied together, so I can cancel out these terms. And I'm left with sine x over cosine x, which is tangent x. And tangent x equals tangent x. All right, our last example for this video, we have cosecant squared minus 1, all divided by cosecant squared, and then equals cosine. So I'm going to try and keep this simple side and get my more complex side to match that. So I'm given that cosecant squared, sometimes when I see this, when there's a squared, it's helpful to know to do your Pythagorean identities. So we've got sine squared plus cosine squared equals 1. How does this help us in this instance? We know that let's divide each thing by sine squared. So we're left with 1 plus cotangent x, or cotangent, cotangent squared equals cosecant squared. And this helps me out. I've got a cosecant squared in my problem, and I can subtract 1 from each side, and I get that cotangent squared is equal to cosecant squared minus 1. And this is one that I can definitely use in here. So I'm going to put cotangent squared in my denominator, or my numerator, hello. So this gives me cotangent squared is now the top, and then over cosecant squared. Sorry if that not carrying the x is bothering people. And so what I'm going to do from here is I'm going to break everything down into sine and cosine. See if that kind of moves our work along. Cotangent is cosine squared, cotangent squared over sine squared. And cosecant is 1 over sine squared. Cosecant squared is 1 over sine squared. I'm going to do that keep, change, flip again to multiply by the reciprocal of the denominator. I'm left with cosine squared over sine squared times sine squared over 1. And these are 1 in disguise, or I can cancel those out however you like to think of it. And I'm left with the left-hand side equaling cosine squared equals cosine squared. And I have proven or verified this trig identity. Hopefully this video has helped, and you have a great day and have some fun.